So for 31, we want to eliminate the parameter to express the following equations as a single equation in x and y. So we're given x is equal to 2 sine of at and y is equal to 2 cosine of at. And the way that we're going to eliminate the parameter is by using this trig identity here, which is the squares. So to get the squares, we have sine and we have cosine, so we have to square both sides. So let's go ahead and do that. So on the x equation, if we square both sides, we get x squared is equal to 2 squared times, sine squared of 8t. And similarly, if we square the y equation, we get y squared is equal to 2 squared times cosine squared of 8t. So once we have squared both sides, we can see that we do have the terms that we need to apply the identity, because if we apply the identity, it means that we get rid of the trig expression, and therefore we get rid of our parameter. So what we're going to do here is now add these equations. So let's add the left-hand side. We get x squared plus y squared is equal to, and now let's add the right-hand side. So 2 squared is 4 sine squared of 8t plus, that's going to be 4 cosine squared of 8t. And now what we're going to do here is just factor out the 4 on the right-hand side. So we have x squared plus y squared is going to be equal to 4 times sine squared of 8t plus cosine squared of 8t. And once we're here, we can apply the identity, because the identity just says, hey, if you have the square of sine of whatever angle plus the square of the cosine of that same angle, that's just equal to 1. So we're going to rewrite this as x squared plus y squared is equal to 4 times 1, which is just 4. So this over here is our parametric equation. And the description of this is just a circle that with radius 2. So this is a circle centered at 0, 0 with the radius of 2. So that is it. We have eliminated the parameter and expressed it as a single equation in terms of x and y.